Ratios and rates. A ratio is a comparison of two quantities. We often write it as a fraction using the order that it was written. In other literature, you may see it written with a colon. A rate. A rate is a ratio that compares different types of quantities. We also write it as a fraction, but need to keep the units since they are different. A unit rate is a rate, so still a ratio, that has a denominator of 1. To get a unit rate, we will divide it out. This is often a more useful rate because you are able to see how much of something for just 1 unit. And a unit price. Unit price is a unit rate, so still a ratio, with money. It tells you how much something costs per unit. You can use unit price to compare items and see which one is a better buy. The item with the lower unit price is the better buy. We'll look at some examples. Our first one, write the ratio of 1 to 2. So we're going to write it as a fraction in order. Whichever one is first should go on the top as the numerator. In other literature, you might see it written with a colon, and I just want you to understand that so you will know it is something that you have been working on and you'll know how to work with it. Our next example, we're going to write the ratio of 9 weeks to 12 weeks. So we're going to make it as a fraction in order. And we will reduce. 9 and 12 have a common factor of 3, so we can divide by 3. 3 will go into 9 3 times, and 3 into 12 will go 4 times, and we can leave the unit off because they are the same. Our next example, write the ratio of 10 days to 4 days. We'll write as a fraction in order, 10 days compared to 4 days. The unit will cancel because they're the same and will reduce for the fraction. There is a common factor of 2, so we'll divide by 2. 2 into 10 will go 5 times, and 2 into 4 will go 2 times. We will leave it as an improper fraction since we would like to write the ratio as a fraction. Next, we'll look at a problem that requires a little bit more simplifying. We'll write as a ratio in lowest terms 7.7 compared to 10. So first we make our fraction 7.7 compared to 10. But we're not allowed to leave a decimal inside a fraction, so we would like this decimal to move over to the end. We can get it to move if we multiply by a power of 10. We need the power of 10 that has as many zeros as we would like it to move decimal spaces. So a 10 will work because 10 has 1 0 for the 1 space. So we're going to multiply by 10. Now we can't just multiply by 10 because we would like to. What we can always multiply by is 1. So if we do 10 on the numerator and 10 on the denominator, we've really multiplied by a form of 1, which is always okay to do. 1 is the multiplicative identity, gives us back an equivalent quantity. Once you have this, don't cancel on the diagonal like normal multiplication of fractions because you need the 10 on the numerator to make the decimal move. So we'll multiply 7.7 times 10. We'll move the decimal over to the end to give us 77. We also have to multiply out the denominator. 10 times 10 equals 100. And now we have a fraction in lowest terms with no decimals. Here's another example that requires a little more simplification. Write as a ratio in lowest terms 3 1/3 compared to 4 1/6. First, we will write it just with our definition of a ratio, which is writing it as a fraction. So 3 1/3 compared to 4 1/6. But we're not allowed to leave a fraction in a fraction. That gives us a complex fraction. So we want to try to simplify it. The first thing I would do would be change to improper fractions. So on our numerator, we can do 3 times 3 is 9 plus 1 is 10 thirds over our denominator. 4 times 6 is 24 plus 1 is 25 sixths. And now we have a complex fraction. Remember, we can write it across as divide instead of in the vertical form. So we can write it across 10 over 3 divided by 25 over 6. So we'll need to change that to multiplication and invert the divisor. So we're going to change it and invert. So we're going to have 10 over 3 times 6 over 25. And now we have fractions to multiply. Remember, when you multiply fractions, you can divide out common factors on the diagonals. So on this diagonal, we have a common factor of 3. We'll divide it out. 3 goes into 3 one time, and 3 into 6 will go 2 times. On the other diagonal, we can divide out a factor of 5. 5 will go into 10 2 times, and 5 into 25 will go 5 times. And now we will multiply across. So on our numerators, we have 2 times 2 is 4. And denominators, 1 times 5 is 5. Now we have a ratio in lowest terms. Next, we'll write an example as a rate. So write as a rate 14 lab tables for 28 students. We still are going to write it as a fraction. It is still a ratio. It's just a little more specialized. It has different units, so we need to keep the units. So 14 tables for 28 students. And then you're going to reduce your fraction. There is a common factor of 14. So 14 goes into 14 one time, and 14 into 28 will go 2 times. We need to keep the units. So there is 1 table for every 2 students. That is our rate. Our next example, write as a rate 18 gallons of pesticide for 4 acres of crops. So we're going to write it as a fraction, 18 gallons for 4 acres. We'll reduce common factor of 2. 2 will go into 18 9 times, and 2 into 4 will go 2 times. We're going to keep the units since they're different. So 9 gallons for every 2 acres. This brings us to a more useful type of question that we would often like to know, and that would be how many gallons for just 1 acre? And that will be a unit rate. To find the unit rate, we will need to divide it out with long division. So we'll do 2 into 9, and that will go 4 times. 4 times 2 is 8. Now you can choose what to do with your remainder. If you want to write it as a fraction, you could write it here, 1 over 2, so 4.5. I'm going to write that on this side. So if I took my remainder as a fraction, 4.5 gallons per acre. You can keep your unit as a fraction. If you wanted to do your remainder as a decimal, you would add a decimal after the 9. take it straight up, can add a 0 and bring it down. 2 into 10 would go 5 times. 5 times 2 is 10. And this would also give us 4.5 gallons per acre. Either answer would be acceptable. We'll look at one more example of writing as a unit rate. So the word unit is what tells you to divide it out because you want a denominator of 1. So we have 420 feet in 3 seconds. But we want to know how far in just 1 second. So we're going to use long division. 3 into 420. And 3 into 4 is 1. Subtract, bring down. 3 into 12 is 4. And bring down. 3 into 0 is 0. So this one goes evenly. 140, you need to put your unit on. You can make it like a fraction. Feet per second.